Recording in progress.
Awesome. Okay. Proving identities. I know you guys done this before, should be review. I'm going to show you one of the problems I gave on my test last year. If I have time, if not, I'll do it Thursday. It was kind of brutal. Or maybe it's not appropriate to do today because I don't think we're doing any multiple angle identities today. But it was a pretty brutal one because, I want to challenge you guys, obviously, right? We're an honors class. But when you prove an identity, usually a good rule of thumb is choose one side, left-hand side, right-hand side. In fact, I'm going to make that a requirement. The reason I'm going to make that a requirement because I'm forcing you to use identities. I'm also forcing you to think more critically too. Because if you work on both sides simultaneously, sure, you could probably verify it, but then you make the problem a little too easy for yourself. I want to challenge you guys a little bit. So we're going to choose one side, manipulate that side using algebra or trig identities, and make sure it looks like the other side, right? Now, remember, whatever side you choose, usually choose a side that's more complicated, right? And make it look like a less complicated side. And remember, there's an intention. You want one side to look like the other. So you want to be able to purposely use some identities that makes one side look like the other. Do consider some algebraic manipulations like factoring, foiling, expanding, fractions, combining fractions. Difference of squares might be a good idea to try. Conjugates. So anyway, that's what's happening here. It does say try both sides, never simultaneously. That's because mistakes could happen. I don't think we need to do that. I think we're just gonna work on one side. And sometimes it may not be obvious what side is more complicated. In fact, actually, it might be a tie, and it might be fine either way. Let's look at example one. Oh, another thing too. Anything that's not sine or cosine, convert it to sine or cosine. That could help too. So use sine or cosine as a bridge to prove that one side equals the other. And remember, these are identities. The left side is identical to the right side. If I went to Desmos and graph the left side, graph the right side, they'd be identical graphs. Or if I plug in a random number for x that fits a domain of force, the left side would equal the right side if I evaluate it. So we expect that to happen. So, I don't know. Let's work on maybe the left side. The reason I'm choosing the left side is because I think I could do stuff with it, right? Because I have a plus, I could do stuff with it. What's tan in terms of sine and cosine? And a cotan's the opposite, right? And when I do this, because I'm lazy, you know what that means? You do double quotation marks. Same thing means repeat, exactly. So we're going to keep the right side the same. I'm not going to, you don't have to rewrite it because it becomes kind of tedious, right? What algebraic manipulation should I do with these two fractions? LCD, what is it? Perfect. Thank you, Thomas. So yeah, cosine x times sine x. So this is going to be sine x times sine x. And here it's going to be cos x, right? So if I do that, I should get this. Sine squared x plus cosine squared x over cos x times sine x. A-okay so far? What's the top? 1. And can I separate out as secant x times cos x? Yeah. Oh, sorry. Times cosecant x. I'll do a little check mark that's verified. Okay. So that's okay? Proof works? Okay. I'll do 2 as well with you guys, and then I'll have you guys try 3 and 4 on your own. Okay, for example 2. I don't want you cross multiplying, because again, I'm trying to challenge you guys a little bit. Let's work on the left side. And what do you think I'm going to multiply top and bottom by? Yeah, because we want to be incredibly intentional, because think about it. Do I see 1 plus sine x on the other side? Yes. So let's introduce it to the left side, in the hopes that things will cancel out nicely afterwards. But remember, fair treatment, you got to do this both, right? Okay, you have 1 plus sine x times cos x. Okay, A-okay so far? What trigger am I doing now? What's 1 minus sine squared? Cosine squared x. Do things cancel, guys? Yes or no? And then you get what you want. We get what we want, which is 1 plus sine x. And we'll check mark is verified. We good? Okay. I think example 3 is pretty obvious. You want to work on the left side for number 3. And example 4, probably the same thing, work on the left side as well. Okay, I'm going to freeze my screen. Good in?
Mr. Bad.
Good. I'm happy to hear that.
So bad.
All right. Yeah, they're fun. Yeah, thank you, David. I think so too.
They were not fun.
Oh, I'll give you some really fun ones. You just wait. You just wait. Okay, first one's pretty easy actually.
Oh, actually, I don't need that. I don't know. No, because 1 minus sine squared is 1 minus sine squared. Oh, I thought I'm really stupid. Oh yeah. And then I did. Oh my god.
Oh, I figured it out.
Oh my lord.
All right. These are pretty short identities, not too hard. But where's the one? So those example 3, I converted the first expression to cosine squared x. Everything cosine cubed x, which obviously equals the right side, so we're set. For example 4, I distributed with convert cotangent of cosine or sine, and for tangent to sine or cosine. By doing that, the sines cancel for the first group, second group, the cosines cancel, leaving the cosine x plus sine squared x, which equals the other side. Verified as well. Okay. So all's good there? All right. Okay. Yeah, Zay, go ahead. What do you mean?
So.
Nothing. That's just repeating the side. Yeah, that's what the quotation marks just repeats the previous step. That's all.
Mr. E,
Yeah.
you care if we put the quotation marks? Or could we just do something like this?
What do you do?
I just like leave it blank and then I'd eventually
Well-
put like an equal statement.
Yeah, I kind of do actually.
Okay.
Yeah, because you gotta just show me the steps. It's part of an algorithm because this is an algorithm in a way. All right. Okay, let's do some more, guys. All right. I'll kind of give you a little push for some of these. Actually, you know what? You guys are doing great. Why don't you guys keep verifying 5, 6, and 7 in your groups again? I'll come around and check on you guys. Just keep verifying. All right. I'll do them really quick and I'll come around and check on you guys.
Right. No, but we didn't know. No, but they're right.
Make one of them, make six, like on 4, and the plus on 4 behind this one. Then sign 4, minus 3.
No. Wait.
Come on. Come on, we're almost there. I'll be there. I'll be and 6-1.
Example 6 is a little crazy. Let me know if you're stuck.
I don't think you want to separate. Oh, you add them. They're both in the prison. What the
Oh, you wanna know this?
Oh, turn the bottom.
So.
I forgot how to get.
It's put it in the sign, that's the wrong thing.
No, I don't. Yes, I got here. What? Oh, wait.
Yeah, 6 is a doozy.
Yeah. You're not adding this to the.
Oh, there are multiple. Oh, there's multiple.
There's the look.
We got.
Right.
Yeah. Wait, am I doing this or what?
Okay, hopefully you guys are cool 5 and 6. 5's pretty short. Back to the left side. You get cosine squared plus sine squared. If that can never come out.
I made the go down.
Example 6. I'll explain. I'll explain. Give me a moment. 5 are okay. Okay, 5. Good. Okay. Example 6. So work on the left side. Make that sine squared with cosine squared. Good. Sine squared with 1. And it could be a fraction is 1. LC is cosine squared. So multiply top one second fraction by cosine squared A. You get that. Factor out sine squared A. We're okay with that so far?
Yeah.
Okay, you have this. Now that's sine squared A. 1 minus cosine squared is sine squared. Also, what's sine squared with cosine squared? What's sine with cosine, guys? Okay, there you go. That's how you do it. So I did 2 steps at once. When I combined these two, you get this, and that became that. Because remember, when you have a product, okay, when you have a product, you could break it off like this. This could just break off times that. This is not a plus in between these two. This is not a common denominator, right? Now what's happening is that we have something times something over something. It's a bunch of factors. So I can pull that out to make a sine squared over cosine squared is that, and that becomes this. Does that make sense? I just kind of like broke them off.
Yeah.
Yeah, no, I can see the confusion. When you decompose a fraction, that's where it get a little tricky. That's where we have to just kind of be careful what we're doing. Okay, let's look at example 7 now. And then we'll talk about some different formulas. 12:50, I'm doing time. Still doing great. Okay, let's keep moving. Okay, for example 7, I would probably work on the right side. I know it's not terribly obvious sometimes. But if you see an opportunity to do a conjugate, I would. Right? Because then I can make it look like the left side more easily. Don't distribute that cosine x. We want things to cancel out nicely. Okay, so let's take a step. Oh, I made a mistake. Do you see a mistake I just made, guys? So I copied something down wrong, which happens. Totally happens. Hold on. Okay, I am going to distribute now. So let me back up a little bit. Okay.
You just simplified, yeah, cosine edge, just the back denominator, and then you split it up.
You're right. You're right. You're right. You're right, Kieran. You got it.
Also, if it's.
I was overthinking it. Okay, so then you got
Oh, yeah.
they are, aren't they? Thank you. I think so too. All right. So yeah, again, the intention is that you want a plus in between. And you need tangents, so sine or cosine, getting that coming out would be great. One cosec, let's get to that seat that. So yeah, we're good again. We're good again. Okay. Yeah, let's do let's let's wait till we get to example 8. That would be good. Right. Okay. Some difference trig identities. All right. So first of all, this is not a thing. Please don't do that. So someone might think sine's distributive. Sine is not distributive. You gotta still respect order of operations. It's a function. I mean, if you work it out, let's try it. That's gonna be sine of 3 pi over 6, I think. And that's gonna be root 3 over 2.
Yeah.
Yeah, because that comes 2 pi over 6, right? And that's gonna be 1. Okay. That's not true, guys. Sine is not distributive. Please don't do that mistake. No trig function ever distributive. Never. Okay, instead, if you want to work with this, there's an identity that is devoted to like adding 2 angles inside the sine function or subtracting it. Likewise, a cosine, tangent, cosecant, secant, and cotangent. So you can't just do that. Don't do that, please. All right. So then what do you do? Question on this one? Why we can't do that? It's not okay. Yes, I will. Some indifference, I will. Because those are hard to figure out why they work. But from there, like the double angles and other stuff, you're going to derive the other ones from that. But no, I give that to you. That's the one thing I'll give to you. Why, did he not give them to you? Okay. Up to this point, I would not give anything to you guys, but now I will.
We're not gonna.
I want you to memorize it. Just you. Yeah. Okay. Okay. So no, we don't have to memorize, but let me help you understand how to read it. Okay, because the plus minus is a little tricky. The order in which the plus minus is put in matters. Okay, guys, focus. It totally matters. Order in which the plus minus is put in matters. Mathematicians are credit OCD. Like my wife is like gets upset that I get so OCD about stuff, but there's a reason why my life is this way. You have to look plus minus, plus minus, plus minus, minus plus. Okay. Ooh, that's kind of tricky, right? Plus minus, plus minus, minus plus. So you gotta be that detail oriented, right? You have to. So we're gonna try one of these, and then we're gonna verify our answer using Calabria, see if it gets us the correct answer. So let's take a look at example 8. Now, when asked for the exact value, it means no decimals, okay? Decimals are not cool. They do not want decimals at all. So we need radicals. So cosine, we use this formula, of course. Now, what 2 angles add up to 45 that I can get from the unit circle? What 2 angles can add up to 75? 30 and 45, exactly. Or 45, 30. The order doesn't matter. because it'll all be the same. Because you're adding, right? So I'm going to do cosine of 30 degrees plus 45 degrees equals cosine of 30 degrees times cosine of 45 degrees minus sine of 30 degrees times sine of 45 degrees. That's going to be root 3 over 2 times root 2 over 2 minus 1/2 And this makes sense because root 6 minus root 2 is a positive value, right? Root 6 is bigger than root 2. And 4, of course, is positive. 75 degrees in the first quadrant, we should expect a positive answer. We do. Root 6 minus root 2 over 4 will be the cosine of 75 degrees. That's the exact value of it. And that's how you can use an identity to do that. Now, Alex, should I just go to, okay. So let's verify this. What was it again? It was okay.
I think 1/6.
Oh, yeah.
Not gonna expose my password. Okay. All right. Anyway, so please give me the exact value of cosine 75 degrees. Let's see what this guy says. Okay. What angles could you use? Let me think. How about 30 degrees and 45 degrees? Great choice. All right.
Oh, like makes you do it.
Oh, yeah. Okay.
Oh. Let me think.
Oh, I thought-
Not how I touch something. This is not how I touch jacket. What was do?
Okay, because I know what I'm doing, it is a little tricky because you have to be mindful of symbols as well. Like exponents, you have to use like a caret symbol. Okay. Okay.
I would get one there. You were literally like
Okay, but it tells me, okay.
You're like the target. Yeah, right now. Yeah. I don't know why you're the target. Oh, great. You're like in
All right, okay. All right, it's kind of neat. So
You talk to the AI way more than I do.
okay.
I'm just like, tell me what.
Okay. Actually, now I get the answer.
Wow, that's a guy.
Okay, all right, there we go. I did. And there we go. Can you simplify further? This is kind of fun. I like this. This is cool. Can I simplify further?
It's a little.
All right.
Oh, I like cut off. I see. Just that, you know.
You get points for being friendly.
So like what happens when you reach like 1,000 points? They're like, oh, you'll just have to find out.
You go down.
Yeah. Shadow.
Okay, I'll stop. All right.
Ask him what we should do.
What do you mean?
Like what would I do?
I'll talk to the point, ask the issue, so we get out, or like, I put up homework.
Okay, good for the moment. It's time. It's big difference.
Oh, wow.
It's going
Right.
Wow.
Last
Okay.
game.
Oh, we should.
Real word applications.
Quizzes.
Nah.
Oh, no.
Be mean to it and see what happens.
Later. All right. Okay. See, and so what was the URL again, Alex? I'll put in Schoology for you guys, so you guys can check it out too. Yeah, try it out, guys. Yeah, it's a little more geared towards math instead of Chat GPT. So what was app.co? Okay, cool. All right. So
One thing that Gus mentioned was like how you have to type in the symbol yourself. I think we're gonna build something so that you don't have.
Right.
To do it yourself.
yeah, because exponents is a little tricky.
Yeah, so
Yeah.
things that you guys tell me to do, I think I said this yesterday too, but we'll make adjustments.
Okay.
So,
Will there be a feedback button or
well, and then once they're done using it, they should do this survey actually that we have. up on-
I'll put in there as our homework.
Yeah.
Yeah, I'll do that. Okay. All right, guys, let's keep moving, guys. We got more to do. All right, that was a little fun. All right, so let me set up the other ones. We won't work through them. So let's just set them up because I know you guys could do unit circle. But just as a setup, now we're dealing with radians, right? What two radians can I subtract to get pi over 12? Good. I like that. Thank you, Lauren. Yeah, pi over 3 minus pi over 4, right? So you should get because that becomes 4 pi over 12. Right? Because that's the same thing, right? But then I'm going to be using the sine formula, which actually I do have memorized, sine pi over 3. But I will be honest, if I don't teach this stuff for a year, I forget the stuff. So that's what I'm giving to you guys. I'll work it out just for the heck of it. That's gonna be what, root 6 over 4 plus root 2 over 4, I think. No, wait. I'm making a mistake. That doesn't make sense. Hold on. Oh, it's a minus. Yikes, guys. I made a mistake. There's a minus right there. My apologies. I knew something was off. Yes, it was the same thing because it's a complement. Yes, that's right. That's right. You get that. Okay. Zay, go ahead. Guys, quiet, please. Thank you. No, you don't need to. That's gonna happen for part C, I think, I believe. Yeah. Hey, Sean, go ahead.
I'm a little bit confused on this one.
I'm gonna get there in a sec.
Okay.
Yeah. I'll get there. Wait, that was which number? Sorry.
13.
Yeah, I'll get there. Okay, guys, let's keep moving because we got a lot more to do. All right. I know, very exciting. So think of it like this, right? Yeah, go for it. Yeah. 3 pi over 12 plus 4 pi over 12 is 7. Guys, quiet, please. It's 7 pi over 12. That's gonna be pi over 4 and pi over 3. Right? Now, that formula is gonna be, again, I forgot. I'm gonna look at it. Okay, I'm gonna add them first. And it's gonna be intuitive. I'm gonna do tan pi over 4 plus tan pi over 3. Then it's gonna be counterintuitive down below. It's gonna be, geez, 1 minus tan pi over 4. Okay. That's root 2 over 2. Plus, oh goodness, I hate these. Root 3, I think. Is that right? 1 minus root 2 over 2. Do you guys get that?
I think the numerator is 1 plus root 3.
You're right. I'm losing my mind, guys. You're correct. Thank you, Zaid. So you wind up getting this 1 plus root 3, 1 minus root 3. Now, in this case, stop. Do not go any further. I'm cool with radicals in the bottom. If you felt going further, you can multiply top and bottom by 1 plus root 3. If you wanted to go further, you can. I'm cool with that. Please don't cross these off. You guys have learned that. There's a plus and a minus, PEMDAS, right? It's like a parentheses up top, parentheses down below. Can't cross it. Now it's times. What times root 1 times negative root 3? Sure. Then the answer is -1. But don't do that. Please, please, please. Respect the order of operations, leave it like that. I'll be incredibly unforgiving to make that mistake. All right. Now, here you're going opposite direction. I give you the right side identity, right? I want the left side. So where did it come from? Well, I see 2 cosines and a minus and 2 sines and a minus. That's going to come from this. Cosine of A minus B. Or cosine, you are correct. Thank you, Thomas. Wow, you guys are on it today. Teachers, I already made 2 mistakes. Yeah, so it'd be cosine of 3 pi over 12. So if I work out in all its glory, because I don't know what cosine pi over 12 is. I don't know. I mean, yes, I could work it out using an identity, but I'm not going to do that. But then I have to do it again for sine pi over 12. That's a pain. I know cosine pi over 6 is root 3 over 2. Sine pi over 6 is 1/2. But if I recognize the fact that this is the output of the sum and difference formula for cosine, or the difference formula, sorry, the sum formula, and realize, that's A and B, great. There's my A and B there. Oh, awesome. Okay, that's root pi over 12. Okay, pi over 4. Okay, root 2 over 2. It will come out that way eventually. We know that. So we don't actually have to compute these individually, not necessary. Same thing here. It's a plus and a minus. That's the same thing as saying tangent 60 degrees, which is going to be root 3. Because remember, that's tangent of 11 degrees plus 49 degrees. That's using the sum formula per tangent. Yeah, go, Thor. Yeah, right. Okay. Good so far? Okay, let's keep moving. Looking at the time. Yeah, we can squeeze more in. Let's keep trucking along here. All right. Okay. I love these problems. These are some of my favorite problems because this requires you to know your right triangle geometry, know SOHCAHTOA. Guys, quiet, please. Thank you. All right. So this is going to be sine A times cos B plus cos A times sine B. And we have 2 triangles. The first triangle, or first angle A is what quadrant? Q what? Second one, Q2. So you're going to draw this for A and this for B. Okay. Let's use different, sure, go for it. Yeah. 4, 5, -12, and 13. So that's going to be 3 and 5. Yeah. Okay. And just do it. Just be careful. 4/5. Denominator should be 65, I believe. -12 over 13. 3/5. And 5/13. You should get -48 plus 15, -35. Oh, sorry, you're right. Is it -33? You're right. Yeah, take away 15 from 48. So I can't do a simple arithmetic, right? Now, how do you know if you did this right? How do we know? Okay, this is gonna be a little, because we're just taking some of this leap of faith. Like, what if I made mistakes somewhere, right? Because I noticed I was kind of hesitant, right? Like I was like, did I label the sides right? Am I right quadrants? Am I do my arithmetic correctly? So how can you verify this? You could do a couple things. I think you could try. No, there's only one thing I could really think of. Here's what I'm gonna do. I'm gonna go to my graphic calculator. Oops, wrong place. Hold on. Come on. And actually, this is nice kind of way to tie it to close the loop on the last bit of the notes from the previous unit where I didn't get to using the calculator for inverse trig. So sine A is 4/5. If I do the inverse sine of 4/5, and let's keep it in degree mode. Whoa. You're right. It's like, well, yeah, I knew that didn't make sense. Thank you. Third mistake today. All right. You get 53.13 degrees. So angle A is 53.13 degrees, right? Now, angle B, it's going to give me the second quadrant because it is part of the default range. If it's not, I have to make an adjustment. I'll tell you later how to make that adjustment. Okay. So if I add those up, and I will be kind of honest with you, when I was your guys' age, there's a test. So you guys like do SAT, ACT, right? Talk to your parents, ask them what tests they took at the end of college. They might mention something like SAT 2 exams or SAT subject tests. And we had to do extra tests to get into college. Like UC's especially had those as a requirement. There was one that was like more pre-cal based called the Math Level 2 exam. And I forgot these ideas. So this is what actually I did as a multiple choice test. I would actually do this, which is kind of dumb, but I worked fast and I got it done. And I got a good score. I guess out of 100?
70.
I got a broke score. Come on, dude.
Okay.
Yeah, come on. Oh, sorry. I should be more humble. Be humble, be simple, right? Okay. But no, first time I didn't get. First time I got like a 730, and I got 800. But I took it out. Yeah, I know. And I took it, and I took the second time after an AP, after I started AP Calculus, so I was much better. Yeah, I know. Yeah. Okay. All right. Anyway, guys, I know. I'll stop bragging. Okay. So when I add those two angles and take the sine of it, I get this. Now, what did I get earlier on? I got -33 over 65. Is that the same thing? And it is. So that's how I know it's a little roundabout, but you could do inverse sine. That's fine, please. You do inverse sine, get angle A and B, but make sure it's in the right quadrant. If it's not in the quadrant we want, we have to make an adjustment, which I'll show you guys how to do that in just a moment, because there's a place we'll do that. And then add these two angles in here, work it out. It should be the same thing I got when I got the fraction answer. It should be the same thing. I did terrible verbal, by the way. My verbal score was awful. So, the verbal, like the vocab on the SAT. There used to be vocabulary on the SAT. On the SAT, like they have reading and writing on the SAT. It used to be called the verbal section. What was that? No. It's English type stuff. That's what I meant. So. All right, let's keep going, guys. Let me see. Okay, proving. Okay, I'm gonna skip these for now. Okay, I'll skip this in the interest of time. But you could use. I mentioned this actually a while ago. You could use. No, I actually mentioned G pyramid. This guys yesterday. You can use the difference form for cosine to verify that this gets you this, or you can let the two angles be x and x, So you could do this, guys. Guys, stop. You x plus x. So if you did something like this here and worked it out, you would wind up getting this. That's why I don't give you double angle identities, because you can verify it or prove it from the sum formulas. But we're gonna skip those for now. We'll get back to them on Thursday. Likewise with 12 and 13. I want to jump to 14. Okay. Okay, we want to analytically solve this equation. All right.
Oh.
So what we're gonna do is I'm gonna use a sum or difference identity in each of these cases. So sine x times cosine of pi over 3 plus cosine x times sine pi over 3. And just for a bit of contrast, let's use a dark blue here. Plus sine x times cosine of pi over 3 again. Geez. Minus cos x times sine pi over 3. All equals 1. Now, some things will cancel out very nicely. What cancels out? Yeah, those just go away, right? So you wind up getting 2 sine x times 1/2, or sine x equals 1. Because remember, cosine pi over 3 is 1/2, and you have 2 of them. So x is going to equal pi over 2. And you can use Desmos to verify that if you want. Or Calabria, but Desmos might be a little more reliable right now. But yeah. Even though it looks pretty
Weird, crazy. If you just work each one individually using identities, you're like, oh yeah, a bunch of expressions cancel out. And I got 2 other expressions I can combine very nicely, or like terms in a way. Oh, and I could divide it cosine pi over 3, which is 1/2.
the 2 1/2 cancel, sine x is 1. I know where that happens at pi over 2. And we didn't ask for a general solution, asked for a very specific solution. So that's how I can analytically solve that one. Questions on that one? Let's see if we can squeeze in one more. Really quickly, coming back here again, for example, 12. I didn't really give you a hint, but I should. You're going to want to do this, just so you know, and then use the identity afterwards. So you're going to want to do that for example 12. We're still skipping it, yeah. But I'm just saying how you would do it. All right, last one. Okay, I think we can get this done here. You're told to start by squaring both sides, because that's kind of crazy the way that looks right now. Like I wouldn't even know how to get started if I didn't know to square both sides. So that's a lovely hint. So you have cosine squared x plus 2 cos x. I'm sorry, say it again, Thomas. It's not an identity. Yeah, it's not an identity. So, okay. Thoughts, guys? What should I do next? What should I do about the sine square on the right side? Yeah, make it all terms of one trig function. That's usually a good idea. And then you get this. And the ones will cancel. And you factor out 2 cos x. So x will be pi over 2 or 3 pi over 2. Or x could be pi. But because we had to square both sides, I think we might get an extraneous solution. Pi over 2 works in the beginning. 3 pi over 2 won't work because 1 doesn't equal -1. And pi will work if you were to test it out. So you just get 2 answers. Right. So then what would you do in that case? So it'll be pi over 2. Plus 2 pi k. And pi plus 2 pi k. So if I go backwards, what's coterminal pi over 2? Negative 3 pi over 2. And negative 7 pi over 2. Here, this would be negative pi and negative 3 pi. So that's my first. Negative pi is my first, negative 3 pi over 2 is my second, negative 3 pi is my third. It'll be negative 3 pi. That'd be my third negative solution. And you can always graph it. Go to Desmos. There's a first, second, third. There we go. Negative 3 pi. And let me undo that.
So yeah, it's a little more advanced. I don't think pre-calculus honors does this. This is more of a BC honors question.
This is a really good question. It's more appropriate for your level. Okay. So yeah, for the most part, we got the notes done. I'll put some the homework will be the next 4 pages of this handout. This is part 2 notes or homework 14 handout. So you're gonna be doing 1 through 13 all. I'll post the Schoology later today as well as the video. And we're all set.